Good morning. Well, today we're going to start something new. I'm going to wait a little while longer to give people an opportunity to come in. I know I started just a few minutes late. Just had a difficult time getting my iPad connected, but that's all right. It's all connected now. Yeah, so we're just going to hang out until a few more people show up. Wow, look at that, eh? I don't know if you noticed that. Page 196. Let's take a look at all of our pages. Look at all these pages that we've done. Wow. Look at all that work. Yeah, look at all this work that we've done. Holy smokes. And that's not even from the beginning of the year, because we weren't really using this at the beginning of the year. What was the first thing that we did? Similar triangles? Yeah, they're similar when they share all three angles. I think this was actually in the classroom. I think that we did this in the classroom. And then, yeah, we talked a little bit about ratios. Oh, yeah, and then we talked about slope-intercept form. Boy, we've done a lot of work. We've done a lot of work. Holy smokes. 196 pages. Maybe we'll hit 200 today. Oh, good morning, folks. Looks like we're almost at 10 people. That's great. Okay. Yeah, we're going to start something new today. We're going to be talking about trigonometry. Big topic. Huge topic. Really important topic. I'm just going to change this template. How do I do that? I'll just do this. I'll add this one, and then I'll delete this one. There we go. Select. I want to delete this one. It's time that we start using vertical pages. The heck? There we go. Yeah, with the vertical pages, then I can zoom in a little bit more, and I don't have to zoom in as much. Okay. Still waiting for 10 people. We'll just give it another minute or so. I suppose some people will probably just watch this after the fact. Which is fine. So I finished marking your latest assignment. I returned them. I haven't heard any sort of issues or anything like that, so I assume that everyone got it and you're able to check your grade. I don't know what Google Classroom looks like from a student's perspective. So as far as I understand, you should have, like, for every single file you submitted to me, there should be a separate file with the same file name, except it starts with edited. So the edited files are the ones that I annotated and kind of added some comments and gave you check marks and things like that. So if you're curious where your grade came from, then you can check that, and it should be fairly clear. I have not submitted the solutions yet. I'm still waiting for one assignment to come in. So once that assignment comes in, then I'll post the solutions. But I think that your like the annotations should make it pretty clear what you did wrong if you want to double check. And you can always ask me if you got a question wrong, you're not really sure why it was wrong, then yeah, you can always ask me for clarification. Okay, so I think we can get started now. I think this is about as many people as we can expect. So we're gonna start talking about trigonometry today. Trigonometry. Okay, so trigonometry, this has a lot to do with, well, first of all, I mean, the main focus is angles. That's what we're going to be looking at today. There's also a way of looking at trigonometry with triangles, but there's actually two ways of approaching trigonometry. I mean, angles are there's no way you can avoid talking about angles, but there's two ways you can approach trigonometry. One is with triangles. The other one is with circles. Now, here's the thing. With these two different methods, so these are, I should say, two different approaches. So these are the approaches slash model. So you have two different ways of approaching trigonometry. One is to look at triangles, or in particular right angle triangles, and one is to look at circles. And typically, you've probably like in grade 9, you probably looked at trigonometry through triangles, which tends to be the method or the approach that's easier to understand. The other approach is to look at circles, in particular something called the unit circle. And yeah, so with the unit circle, it tends to be a steeper learning curve. Like it's harder to initially understand how it all works within a unit circle, but it's a much more robust model, and that it's the model that you end up sticking with when you study calculus. So you don't really look at triangles too much in calculus. The focus is really on on circles. So what I'm going to try to do is I'm going to try to show you both models, and we'll try to go back and forth between them. And I think that's probably the best way to approach trigonometry, is to use both of these models and look at the connections between them, and see how they differ, and see how they're the same, etc. So let's take a look at let's start off by talking about angles. So I think at this point we all kind of know what an angle is. So I'm not going to bother defining what an angle is, but I want to just make a couple of things clear. Let's see here. Just want to make sure I've got this terminology right. Okay, so any angle has a vertex. Okay, so I'm just gonna sort of draw a little diagram here, and this will be our model here. So this little point here is, we call the vertex of the angle. Okay, it's like the corner. A vertex typically is the word that we use when two lines intersect. They intersect at a vertex. But there's many other ways that you can describe what a vertex is. So there's our vertex. We have it might seem arbitrary at first, but the more you study this, the more this is going to make sense. You have these two sides of the angle. You have this one, which we call the initial side, and we have what we call the terminal side. And you might ask, well, how do you know which one is which? Like they're both just rays, right? They're like lines, right? Well, the way you can tell which one is which is all angles go counterclockwise. So this is the actual angle, and it is counterclockwise. So it sounds weird at first to think of angles having a direction, but the way that we're going to study them and the way that it will work in the long run is that we have to have a direction in our angle. So our angles are going to have a direction. So what that means is if your angle goes in the other direction, you can actually have a negative angle. So that's something that might break your brain at first, like how can an angle be negative? But the reason we can have a negative angle is because we have a direction. So let's take a look at a few different angles here. So let's see here. This. By the way, we usually use a Greek letter for an angle. Usually theta is the angle that we use. So let's use this angle theta. So by the way, this is theta, and it's a Greek letter, and that's the letter that we'll use most of the time to describe angles. We might use alpha, and we might also use beta. I think some people pronounce it beta. I call it beta. So we've got alpha, beta, and theta. There's a whole bunch of Greek letters. These are the only ones that I think we're going to be using. So anyways, back over here. Here is an angle right here. And in this case, we can have, well here, why don't I erase this? If this is our initial side, and this is our terminal side, if this is our initial side and that's our terminal side, that means that this is a positive angle. Okay? However, if we have something that looks pretty much exactly the same, except our initial side and our terminal side are switched, so this is our initial side, and this is our terminal side, then all of a sudden our angle is going clockwise, and this is what we would call a negative angle. Okay, so that's how that works. Now, the way that we're going to be looking at angles in this case, or the way we kind of model our angles, is what we call angles in standard position. Okay, so we're going to write a little bit about angles in standard position. Okay, so what we do here, the idea is that an angle in standard position, we place the angle on the Cartesian plane. Okay, so the goal here, our goal, is to place angles onto the Cartesian plane. Cartesian plane. Just a quick reminder, what the heck is the Cartesian plane? It's a fancy word for the x, y plane. Just the regular, like a graph. We're basically going to graph angles. Okay? So, when we do this, well, let me just start out by drawing a Cartesian plane. By the way, the Cartesian plane is named after René Descartes. I think I mentioned that a couple classes ago. The Cartesian plane is named after René Descartes. When he was a child, he saw a spider walking on his ceiling while he was lying on his bed, and he looked up at his bed, and he realized that you'd be able to tell exactly where the spider is based on how far he is from one wall and how far he is from the other wall. Basically, like the XY coordinates. And he was the first one to think of that. So pretty powerful thought. He's also responsible for a lot of the results that we have in calculus, and he was also a prolific philosopher as well. So he was a major thinker in the history of thought. Anyway, so I'm hoping that it makes sense that if we were going to put an angle on the Cartesian plane, the place that we're going to put our vertex is right here. So our vertex is going to go on the origin, right? The origin is what we call the point 0, 0, the point where the x and y axis intersect. So the vertex is placed on the origin 0, 0, right? The origin is just a nice way of describing the point 0, 0. So I'll probably refer to the origin a fair bit. Okay, so there's our origin. It's at 0, 0. Now the x-axis going in the positive direction is where we place the initial. I'm actually going to use a different color here so it stands out. So the initial side is placed on the x-axis going in the positive direction. So this is what we would place the initial side. And assuming that our angle is positive, let me find a different color here. How about orange? Assuming that our angle is positive, then our angle is going to go like this, angle, and then our terminal side will go like this, and this is our terminal side. Okay, that's our terminal side. So just a couple of things about the Cartesian plane that I'd like to remind us of. So this is how we would place it. I want to just talk a little bit more about the Cartesian plane in and of itself. Let me just do this so it looks nice. There we go. So the Cartesian plane splits up this plane into 4 quadrants. Quadrant meaning just 1/4, like 1/4 of the plane. So we split it up into 4 quadrants, and we named those quadrants based on how these angles work. You may have already named these quadrants before in a different class. You may be already familiar with the naming of these quadrants, but the quadrants have names based on the order that the angles will kind of spin around like this, right? So so let's just quickly write about the quadrants. Okay, so the Cartesian plane splits the xy plane into 4 quadrants. Oops, QUA. 4 quadrants, we call them quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we use Roman numerals for that. Don't ask why, because I don't know. Well, you could ask why, but I won't have an answer for you. We just use capital Roman numerals for this. Okay, so and we name them in the order in which our angle goes around the quadrants. Okay, so if we had a very small angle, right? If we had a small angle, that angle would be right in here, right? So for that reason, we call this quadrant 1. Okay, if your angle was to get like a little bit bigger, right, then all of a sudden the next quadrant that it would be in the 2nd quadrant. And as your angle gets even bigger, so remember that this is our initial side. This is always our initial side. If the terminal side is over here, remember this is what we would call a reflex angle because it's greater than 180 degrees. So if our angle is going like all the way over here, then this would be our 3rd quadrant. And finally, if our angle is like this huge angle that's going all the way over here like this, Well, that's the final quadrant. That's quadrant 4. Okay, so that's how we name the quadrants, and it's going to be really useful to be familiar with these quadrants. And yeah, so what I thought we could do is I could maybe start naming a few angles, and I'm going to ask you which quadrant the angle falls in, and then we'll actually be able to do some examples and look at some questions. Okay, so here's a question. Which quadrant does 271 degrees lie in? Okay, I'll give you 30 seconds to think about that, okay? So the 30 seconds will start now, so I'll put 20 seconds on here. Okay, which quadrant does 271 degrees lie in? Oh, there you have it. Okay, so just a quick reminder, 90 degrees is 1/4 of 360. So remember, just a few quick facts. Maybe it's been a while, maybe you forget these things. 360 degrees is a full rotation, which means that 90 degrees is 1/4 of a rotation. So this would be like, this angle here would be 90 degrees. This would be 180 degrees. This would be 270 degrees. And we were asked about, and by the way, this would be 0 or 360 degrees. So we were asked about 271, which is just a little bit more. So this would be in the 4th quadrant. Okay, so we'll write quadrant 4. Okay. Okay. What about 400 degrees? Okay, I'll give you 30 seconds to think about that. Okay, what about 400 degrees? I guess that's 20 seconds, but there we go. Time's up. Okay, well, I'm going to leave this up because I'm going to ask a few more questions. Well, let's take a quick peek over here at a rudimentary Cartesian plane and just kind of work our way around it. So this would be where we're at 0, then we would go to 90, then we would go to 180, then we would go to 270. Okay, now we would go to 360. So this is a full rotation is 360 degrees. If we were gonna so like we're almost at 400. We have to ask ourselves, are we in quadrant 1 or are we in quadrant 2? Right? Because I really don't think we're in quadrant 3. Right? Well, if we were in quadrant 2, well, it would be 360 plus 90, which is 450. So this is 450 degrees right there. So we're somewhere between 360 and 450. So it would be right around here. So we would be in quadrant 1. Okay. How about this one? Let's do another one real quick. What about negative 150 degrees? Okay, think about that one for a minute. 20 seconds, go. Which quadrant would negative 150 degrees be in? Oh, so the Roman numerals are used as to not be confused with coordinates. Yeah, okay, that makes sense. I like that. Okay, we're gonna stop it there. Okay, negative 150. So let's bring it back over here. Okay, so here's another little Cartesian plane, and then let's remember this is our initial side here in orange. Not sure if that's showing up very well on the video. If you want me to use a different color, just let me know. I can find a different color. But in any case, this is our initial side. Now, instead of going counterclockwise like we normally do, with a negative angle, we're going in the clockwise direction. So this would be 90 degrees in the negative direction. This would be 180 degrees in the clockwise direction, negative direction, however you want to describe it. So we're not quite there yet. So we're right around there. So keep in mind that the quadrants are still just the quadrants. It's not like if you change the direction, then the quadrants somehow change. This is still quadrant 3. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So yeah, this would be our terminal side here, which lies in the third quadrant. Okay. Okay, here's a new term for you. So you might have noticed that like there's many ways of defining an angle. You may have, like, maybe your initial thought of angles was such that you thought that an angle had to be somewhere between 0 and 360 degrees. But right here we just showed that it's very easy to define an angle that's greater than 360 degrees, and it's also easy to define an angle that's negative, right? However, so yeah, you can have these angles, but you may have noticed that this opens up the opportunity for two angles to be pretty much the same, right? So, for example, so let's consider the angle, let's say 30 degrees. Let's say 390 degrees. And let's say negative 330 degrees. Okay, let's consider all of those angles. Okay, so let's just draw all of these angles and see what happens. So 30 degrees is about 1/3. Well, in fact, it's exactly 1/3 of 90. So 30 degrees goes here. And we started at the initial side, and our terminal side is right there. So this is 30 degrees. Let's do 390 degrees. So 390 degrees, I'll do in a different color. We still start at the same initial side, but we do 360 degrees all the way around, and we keep going, and we have an extra 30 degrees in us, so looks like we land right there. So this is 390 degrees. Because it's 360 plus 30, okay? So we really need to be thinking a lot about our multiples of 360. And then finally, let's do, how about pink? If we were to go in the negative direction, well, that would be, it's 30 degrees less than 360. So because we're going in the opposite direction, we would also end there. So this right here is negative 330 degrees. Okay, so all of these angles have, I should actually say share, the same terminal side. Okay, we call these types of angles coterminal. Okay, because they share the same terminal side. Okay. Okay, so I'm I'm going to ask you a question. I'll give you 2 minutes. So I want you to find the smallest positive coterminal side for these two angles. The first one is going to be, let's see, 2,692 degrees, 2,692 degrees. And the second one is negative 1,940 degrees. Okay, so I'll give you let's say 2 minutes to do that one, and then we'll see how that went. So 2 minutes. I'll give you 2 minutes 20 seconds, and we'll see how you fare for that one. Oh, excuse me. Oh, missed that cue. Okay, let's see how we did here. So we've got 2 questions to do here. So let's see here. So what we're gonna do is we're gonna be looking at multiples of 360 degrees. Okay, so if you've ever watched any like snowboarding on the Olympics, you may recognize some of these numbers. So let's take a look at some of the multiples of 360. So we have, I'm just going to write them on the side here. So I've got 360, and then I'll do plus 360 equals. The next one is 720. After that is 1080. After that is 1440. And then we've got 1800, and after that we've got 2160, and after that I have 2520, so 2520, and after that I have 2880. So these are a whole bunch of multiples of 360. Okay, so I can subtract any one of these numbers from this, and I would get the same terminal angle, right? You'll have to excuse me, I just have to blow my nose. I just sneezed. Pardon me. See, I can subtract any of these because a full 360-degree rotation is going to give me the same terminal angle. So the whole idea here is that I'm going to be subtracting the largest multiple of 360 that is less than 2,692, which is this one here, 2,520. So let's do that. We'll do 2692 minus 2520, and that's equal to, what would that be, 142. So don't forget those degree symbols. And did I get that? No, 9 minus 2 is not 4, 7. Okay, pardon me. Yeah, so that looks a little bit better. So 172 degrees. Okay, let's look at 1940. So, or negative 1940. So here we're not going to be subtracting multiples of 360. We are going to be adding multiples of 360, and we're going to want to find the smallest multiple of 360, which is greater than the absolute value of negative 1,940. Okay, so that would be this one over here, 2160. So I've got negative 1940 plus 2,160, and this I'm actually going to use my calculator for. Oh, that's not my calculator, that's my phone. Is that negative 1940, negative 1940 plus 2,160. And that's equal to 220. 220 degrees. Okay, and these are all degrees. Okay, so yeah, that one's 220. That's not so bad. Yeah, 172. Yeah, I corrected myself. Okay, so that's the smallest positive coterminal side for these angles. So I've got 172 and 220 degrees. Okay. Let's talk a little bit about reference angles. So basically this class is just all about developing some vocabulary because we're going to be using a lot of this vocabulary while we talk about trigonometry. So next up, we've got to learn about reference angles. Reference angles. Okay, so for any angle in standard position, remember standard position is where you actually lie the initial side on the x-axis here. So pretty much all the angles that we've been looking at in the past 10 minutes. So like this is an angle in standard position, this is an angle in standard position, this is an angle in standard position. So any angle that's in standard position has a reference angle. Reference angle. Okay, so the reference angle is between 0 and 90 degrees. Okay, so some angle between 0 and 90. So we calculate this by finding the angle between, I should say finding the positive angle. It's always positive. The reference angle is always positive, which is described right here, right? It's between 0 and 90 degrees. So you never have a negative reference angle. But we calculate this by finding the angle between the terminal side and the x-axis. Okay? So there are 4 different situations, and it's a strange symmetry. It's not the symmetry that you might expect. There is symmetry in it, but it's kind of a strange kind of a symmetry. So there's 4 situations depending on which quadrant your terminal side is in. So let's take a look at each one of those situations. So let's see. So this is the first. Well, why don't I do all 4 all at once? Okay. Well, not all at once, but I'll draw out all 4 situations, and then we'll take it from there. Okay. So there's another one, and here's my last one. Okay. So if it's in quadrant 1, well, then that means that we are left in here. Okay, so in this case, our terminal angle is just the original angle that we started off with. And what I'm going to do actually is let's just call it theta prime. Okay, so if our original angle is theta, then our new angle, our reference angle, is theta prime. So in this case, in when our angle is in the first quadrant, it is its own reference angle, because naturally that angle is between 0 and 90. So that's just right off the hop. That's the easiest one. Okay, if we're in quadrant 2, oops, not that 2. Come on, there we go. If we're in quadrant 2, well, we're going to be left right around there, and here would be our angle. So this is our angle theta. Now theta prime, maybe I should actually do theta prime in green. Theta prime, well, in that case, it was just the same angle. In this case, it's the angle between here and here. Okay? So theta prime is equal to 180 minus theta. Okay? That's the reference angle. It's theta prime. So you take 180 degrees and subtract theta, and that's what your reference angle is. If you are in quadrant 3, well, you can probably guess what's going to happen. So this would be quadrant 3. So our original angle goes all the way around. So that's like an angle like 200 degrees or something like that, just a little bit over 180, but less than 270. Well, the reference angle is this angle right here. So this would be theta prime, and that's going to be equal to our original angle theta minus 180 degrees. Okay? So it's not that we subtract theta from 180, we take 180 and we subtract theta. Or no, sorry, we take theta and we subtract 180 degrees. Okay, finally, if we are in quadrant 4, well, we're all the way around like this, like that. Okay, there's our terminal side. Okay, I'll just try to make it a little bit bigger so my head isn't blocking your view here. The terminal angle is this angle right here. Okay, and so the way we would get that is we would do that theta prime is equal to 360 minus theta. So if this is our angle theta here, we take 360 and subtract theta from it. So those are all of our reference angles. Or sorry, not our reference. Yeah, no, these are our reference angles. Okay, so it's a nice way of just sort of simplifying the angle, and just sort of, you know, boiling it down into just some small angle between 0 and 90. So I think that we're kind of running out of time here, so I'm going to leave you with an exit slip. No homework for today. We're not quite finished this section. There's still a few more terms that I want to ask you about before I assign any homework. In particular, I'd like us to learn a little bit about reflections and how reflections affect our degree. And I also want to talk about the coordinate system. So the coordinate system is kind of where we start to really understand what we call the unit circle. So yeah, let's do this. So the exit slip for today. So I want you to find the reference angle for the angle, let's do 3,294 degrees. So what is the reference angle for that? Okay, so that's it for today. I hope you guys are doing well. I'm gonna sign out, and I will catch you in the next one. What's today? Today's Thursday, so yeah, tomorrow's Friday. Wouldn't that be nice? So yeah, I'll talk to you guys on Friday. Have a good one. Bye bye.